Hello again. We are continuing our discussion of systems of equations, and we've gone through a lot of methods to solve them. There are others, but these are the only ones that we're going to learn in this course. So now that we've learned how to solve those systems, and I've gone through a few examples with you, we're going to talk about how to apply that. We're just going to apply it to real-world situations for today. So first we need to talk about which method you should use and when to use it. So the first method we talked about was graphing. And you want to use that when you want to just kind of approximate where a solution would be. You don't want the exact answer. Sometimes you get the exact answer, but it's not as important in that situation. For substitution, you're going to use that when you have one equation that says y equals something or x equals something. And then for elimination with addition, you're going to use that when the equations are in standard form and one of the variables coefficients are opposite. So you've got like a 2x and a negative 2x. With subtraction, again, standard form, but one of the variables coefficients are the same. So you've got a 2x and a 2x, for example, in the equations. And then with multiplication, you don't have any coefficients that are the same or opposite, so you need to multiply first before you add or subtract. All right, so here's an example. We have Xavier that is 8 years older than Yolanda. And in 2 years, he will be 1.5 times her age. So how old are they now? Well, the first sentence says that Xavier is 8 years older than Yolanda. So if I add 8 years to Yolanda's age, then that will be equal to Xavier's age. The second equation says that in 2 years, Xavier will be x plus 2, and Yolanda will be y plus 2 years old. So that x plus 2 is going to be 1.5 the y plus 2. All right. So I have the first equation is x equals something, so I will use substitution. So everywhere there's an x in the second equation, I'm going to replace that with y plus 8. So instead of x plus 2 equaling 1.5 times y plus 2, that x is going to become y plus 8, and everything else is going to stay the same. So now that equation only has y's in it, so I will be solving for Yolanda's age first. Okay, so on the right, I've got distributive property. I've got 1.5 times a set of parentheses. So that will be y plus 8 plus 2 equals 1.5y plus 1.5 times 2, which is 3. All right, now let's simplify the left side because I see that 8 plus 2, and I know that that is 10. Now I've got y's on both sides, and I only want y's on one side, so I will add negative y to both sides so that it is gone from the left-hand side and only shows up on the right. So I have 10 left on the left-hand side, and I just have 0.5y plus 3 on the right-hand side. Now it's a multi-step equation, so I add negative 3 to both sides, and I got 7 equals 0.5y. And if I divide both sides by 0.5, 7 divided by 0.5 is actually 14, and on the right side I have just y. So now I know that Yolanda's age is 14, and now I can figure out Xavier's age. So I replace y with 14 in the first equation, so instead of x equals y plus 8, x equals 14 plus 8, and that means that Xavier is 22 years old. So Xavier is 22 and Yolanda is 14. Here's another example. I have textbooks that I need to buy, 6 math books plus 3 biology books. They actually weigh 24 pounds. 4 math books and 5 biology books weigh 25 pounds. And I'm assuming they're all the same version of the book, otherwise this would be too complicated, and I need to know how much each book weighs. So 6 math books plus 3 biology books is 24. 4 math books plus 5 biology books is 25 pounds. These are in standard form, so I'm going to use elimination, but the problem is the coefficients of the variables are not the same and they're not opposites, so I need to multiply. So I randomly decided to make the m coefficients the same. So I'm going to multiply the first equation by 2 and the second equation by 3. That would make them both have 12m at the beginning. So the first equation, 6m, is going to become 12m, 3b is going to be 6b, and 24 is going to be 48. In the second equation, if I multiply everything by 3, the 4m will be 12m, the 5b will be 15b, and the 25 will be 75. So the m coefficients are now the same, so I can subtract. 12m minus 12m is nothing. 6b minus 15b is negative 9b, and 48 minus 75 is negative 27. This equation is much nicer because it only has one variable. To solve it, I'm going to divide both sides by negative 9. So negative 9b is divided by negative 9 is just b, and negative 27 divided by negative 9 is 3. So I now know that a biology book weighs 3 pounds. I just need to figure out how much a math book weighs. So I take that b equals 3, and I replace every b with the number 3 in either one of the equations. I randomly chose the first equation. So instead of it being 6m plus 3b equals 24, it's 6m plus 3 times 3 equals 24. And I know that 3 times 3 is 9, so I can make that replacement. Now it's a multi-step equation. So I will subtract 9 or add negative 9 to both sides, and I get 6m equals 24 minus 9, which is 15. Divide both sides by 6, and m is 2.5. That means that every math book weighs 2.5 pounds. And every biology book weighs 3 pounds. Okay, and a final example, there's a factory that makes jeans. Costs $450 per day to run the factory and $10 for each pair of jeans made. So the cost function is y equals 10x plus 450. The company that owns the factory wants to sell jeans at $25 for each pair. So the revenue function is y equals 25x. How many pairs of jeans will they have to make and sell in order to break even? Break even means that their profit is 0. And obviously anything above that is better, but we want to know the minimum amount they would have to make in order to break even and not have to pay more than they're earning. So let's look at a graph. All right, so the first equation is y equals 10x plus 450. So it has a slope of 10 and a y-intercept of 450. So if you look at the x-axis, that goes up by 5s, and the y-axis goes up by 50s. So a slope of 10 means I'm going to go over 5 and up 50. So basically you're going diagonally through each little square. The second equation has slope 25 and goes through 0, 0. So it looks like that there. All right, so basically I just want to see where the lines cross. And I'm just looking for an estimate because remember, I don't actually want to break even, I want to do better than that. So the point where they cross is where x is 30 and y is 750. So they will break even when they make 30 pairs of jeans. Remember, x represents the number of jeans that they have to manufacture in order to break even or make a profit or make a loss. So they should be making at least 30 pairs of jeans per day in order to either break even or make a profit. So that's an example of graphing. So I've gone through examples of each type. I've done substitution, elimination, and graphing. If you have any questions about any of these, please let me know, and I will see you tomorrow.